So I'll talk briefly about the program on data privacy that's running right now this semester. So it's one of two spring 2019 programs. Our organizers are myself, I'm Adam Smith from Boston U, Vitaly Feldman from Google, Katrina Liggett, Kobi Nissim, and Sasha Slavkovich. I guess there's one more organizer whose name doesn't appear here because unfortunately he passed away after about a year and a half ago, but after this program was conceived. And Steve Feinberg, who is a statistician, an eminent statistician at CMU. So the context for the program, of course, is that data and data-driven systems are guiding decisions in many areas of society, and the way in which this is happening is increasingly complex. And we are constantly confronting questions of balancing and somehow understanding how to get the benefits of these enormous data sets that we're collecting and the benefits of the systems that use them, while trying to understand and mitigate the various negative consequences that can come along with those, the costs in terms of privacy, also things like transparency, control, fairness. So this program is really focusing on the privacy part, although these other things come in incidentally, and there's a whole other program that Cynthia will talk about going on this summer, focusing on transparency and fairness. But in a nutshell, the question for the program is how we can make statistically useful information, about sensitive data sets broadly available in a way that's responsible. So when I say sensitive, I mean containing sensitive data, and what's statistically useful, of course, will vary from application to application, but just broadly as useful as possible. So this is the program. This is an Institute for Theoretical Computer Science. A lot of the program is focused on fundamental theoretical questions, developing algorithmic tools, lower bounds, understanding fundamental limits, various frameworks for reasoning about privacy and analyzing data privately. But there's also a strong component of interactions between the technical work and law and policy and ethical questions, with flow going in both directions. We have a number of participants I'll talk about in a second coming from these areas. And we're really trying to understand to what extent technical notions can inform how we formulate policy, for example, and to what extent the various consensuses that different parts of society have arrived at for what is important about privacy in a given scenario should inform technical work. And we're looking at applications in a number of areas, especially in the social and behavioral sciences, although other areas as well. Okay, we have 30 long-term participants who are here on a regular basis throughout the semester, either full-time in residence or coming on a regular basis from other parts of the Bay Area. 8 junior fellows, a whole pile of graduate students, plus other participants who are here on a sort of short-term basis. Background, you get people from a number of areas within theoretical computer science, and they're the bulk of the participants, of course. But also we have a number of people from statistics, ranging in their focus from more applied to more theoretical questions. People with backgrounds in applications in the social sciences, questions about law and policy. We have a number of lawyers who are here as part of the program. And people who think about ethics and questions of sort of trying to formulate to what extent we are capturing various socially important concepts in these technical systems. It's intentional that these bubbles kind of overlap because, as you might imagine, certainly between statistics and computer science, there's a fair amount of overlap in terms of expertise and thought processes, but to some extent with all of these bubbles. So just to give you a sense of the kinds of questions that are coming up in the program, and I'm not, I only have a few minutes, so I just have like a few, some questions, maybe representative problems that people are thinking about. On one end, we're looking at very precise mathematical questions. One of the concepts that plays a central role in the program is differential privacy. Not not the only one, but like the kind of questions we ask there might be, given a well-formed statistical hypothesis testing question, what is the optimal differentially private test? How do we analyze and characterize the structure of the right estimation procedures and things like that? What are the accuracy limits of differentially private optimization? This has come up a lot in the industrial work on differential privacy in the context of fitting neural networks to sensitive data. Also, reasoning about like whether or not the definitions we have for a given context are adequate, are perhaps being too conservative, and so when are they not? So when are there realizable attacks that sort of demonstrate the failures of some of these rigorous formulations, and when are there not? When is there a kind of a gray zone where we have neither working attacks nor kind of any rigorous way to analyze things? And those are obviously places where we look for interesting problems. Various questions that come up about architectures for distributed data analysis. So for example, companies like Google and Apple currently have deployed systems where they're trying to analyze sensitive data that's held on user devices. They're not the only companies doing this. What are the different ways to organize those systems that make sense, either for one company or perhaps a collection of organizations, not necessarily companies? And we're looking a lot at applications for statistical agencies, and specifically the U.S. Census Bureau, which is currently modernizing its disclosure limitation methodology. And so like a typical, an example of a question that came up in the last week and that we were talking about actively is sort of what would it take for the U.S. Census Bureau to provide a useful synthetic data version of what is used to be called the long-term census forms, so it's called the American Community Survey, so the really detailed questions they ask. A subset of the U.S. population. And some of these discussions have focused both on the practical aspects, but also just trying to formulate these questions in ways that are precise enough that we can sort of get a community of people working on them rather than just a small number of people inside the Bureau. And just on another tack, what kind of economic frameworks make sense for, say, cooperative management of sensitive data? So one thing that has garnered some attention recently are things called data co-ops. So this is sort of a collective effort on the part of many individuals to manage data and gain value from their data. What are the economic frameworks, and also what are the legal frameworks that come into play? And this is another example of the flavor of question comes up. So you see a fair variety of different types of questions that require a fairly broad selection of areas and expertise to answer, and that's what we tried to bring together. Okay, thanks.
Questions?
I'm happy to take questions or not. Yeah.
What is a differentially private test?
Oh, yes, I didn't define that. So differential privacy is a specific restriction on. So the context it is for is if you've got a sensitive data set about which you want to publish information. It's a specific technical framework for thinking about how much information about any one individual is leaked by the output of the system. And it's a condition on the system that processes a mathematical restriction on the algorithm that processes the data. And so roughly what it requires is that if for any change in one person's data, the induced change on the probability distribution of the outputs of the system be very small. So it's a condition that's reasonably easy to write down and specify, it has become a fairly certainly well studied, and in many contexts the standard notion of technical notion of privacy. But there are lots of technical questions that remain about the best way to design algorithms that satisfy this restriction, when we can't, what their limitations are, that sort of thing. Other questions? Okay, well, thanks very much.